Hi, welcome to another lesson in the workshop Arduino circuit building. We are going to use 123D circuits. I explained all about that in the first lesson. In this lesson we're going to go into much more detail for building electronic circuits. I'm going to create a new breadboard, so I'm going to click New Breadboard. After I've done that, it's going to load me the unnamed circuit. I'm going to change it to lesson 2. Here we go, and then we're gonna press this button here to go to breadboard view. Here we have it, lesson 2. Okay, let's start with some components. I'm going to explain some properties of components. I already explained something about a resistor, but at the moment we are going to use a battery. I'm gonna put it here. So the red plus is here. I'm gonna connect it, and the minus is here. So now this rail is connected. Good, let's say, design is to properly interconnect those minus here and here. So minus, the rail to the top is connected to the minus rail at the bottom, and the plus is also connected. So I can just pick up minus and plus from the top and bottom of the breadboard. Okay, so I'm going to go to components, and I've got my battery set up. I'm going to get myself an LED. I'm going to put it inside the breadboard, and I'm going to get myself a resistor, and it's not oriented right, so I press R to get it properly oriented. And I'm going to get myself a LED RGB, so I just put it there. I'm going to tell something about an LED RGB. I'm going to tell something about a potentiometer. Put it there as well. I'm going to get some multimeters in there. You can also press the multimeter and then Control or Alt, or I mean Command on the Mac and Control on the PC. You can just press Control C, Control V. So we've got two multimeters. They are able to measure voltage, amperage, its current, and resistance. I'm going to use those to explain some properties of these elements that are there, because this is considered an output element. So an LED is something you can put on the output port of an Arduino, and this as well. This is considered to be an input element. This is where you can control the inner workings of the Arduino with a knob. That's a variable resistance depending upon the angle that you turn it, but I'll get into that in a minute. Okay, and we have the DC motor. I'm gonna put it there, and that's it. So what I want to do is explain to you how this works. We have a LED with the left side is the negative side. We're gonna put it to the negative rail, and this I'm gonna put to the positive rail. So if I run my simulation at the moment, it's not going to you see the LED, it's red, and it's based upon this value. So the current going through from the plus through the resistance, through the LED to the negative side is how much? I don't know. I'm going to measure it. So I'm going to measure the current that goes through here to this loop. And to measure the voltage, you just need to connect this device in parallel to the rails with the voltage. So I'm just going to show you how to do the voltage quick. So I'm going to put the I have to stop the simulation, else it won't work. And now I can draw wires. So let's start the simulation, and we have minus 8 volts. That means I connected it the wrong way. It's like in real life. If you have a multimeter to measure voltage, you can connect it the other way around. So to fix that, let me just delete that and connect this one to that one, and this one to that one. So now I have the proper orientation. So now it says 9 volts. So this battery is also 9 volts. So that's easy to see. Now I want to measure current. So in order to do that, I have to stop the simulation, select the device, and click on this left side here, amperage. So what I want to do is I want just remove these wires again. So this one as well. I'm going to, in order to measure amperage, you need to run the current through the device. So where, like I connect now, it needs to run through, the current needs to run through the device in order to measure amperage, or current in amps. So you have here the plus side. The current goes through the multimeter and through the resistor, through the LED, and then back to the minus pole. So here we go, start simulation, and it's running 7.06 milliamps. So I'm going to click the resistor and change these values a bit. So if I go for 1 ohm, it's 1.18 amps, so that's a lot. So that's too much. So the LED would break, it would just fail, it would collapse because there's so much current going through. 400 amps, and then you can see it's still running. So I challenge you to find out what the best value would be just before it breaks down. So you can just find out by approximately you're going to get around 300 to 400 ohms, and then it's running at its brightest, because if it would bright anymore, it would be more bright than it would be, then it would break. Okay, so this is voltage and amps measured. Okay, and now I'm gonna move to this one here. That's a very nice element you can use in your projects because it's an color LED. It has a, if you look at it, it's maybe not visible, but if you hover over it, over the port, you can see terminal red. So this is the red. Like any color, it's based upon an RGB value, or in this case voltage that's applied to the RGB LED. This left one here is red. This one here is the cathode, that has to be on the negative side, and this is it says blue, and this is green. Okay, I want to copy this thing. I want to copy it. Oh, I have to stop the simulation. Keep forgetting that. Copy. So I copied this resistor. I'm going to get some resistor between the negative side, and this one needs to go to the negative rail. And these three I can just connect. So I can just connect to the plus side here and run the simulation. Now it's red. Okay, so I can just delete this because this one is blue. So I can move this to the red. Hey, it's blue. And any mix. So I can move to green, put it on the positive rail here. Now it's green. You can also mix colors. So blue and green would give this color. It's a magenta, I think. Anyway, that's how you can create any color you want just by applying the right voltage to the right pin. Okay, another device I want to show you. This is called a it's a potentiometer. It says meter. It's strange, but it's not really metering anything. Well, to show you how this works, it has 3 terminals. It's called 3, and it looks like this. I looked it up on Potmeter on Google, and it looks like this. This is the resistive coating inside the pot meter, and it's the wiper. This is called the wiper, and this one here, if you turn it, depending upon the position of the wiper, it would have on the left side more resistance and on the right side less, and the other way around. So in order to show you how that works, I'm going to get myself no, I'm going to copy it. Oh, I have to stop simulation, of course. Copy, paste. So I've got two little, I can just do it like that. So I want to measure the resistance between these 2 points, and I want to measure the resistance between these 2 points. Run the simulation. Oh, and I have to stop the simulation because I need to switch them to resistance. Switch them to resistance. Start the simulation. There we go. So now you see the left side is getting more and more kilo ohms, and the left side is decreasing the amount of kilo ohms. So between these two terminals, there's 230 kilo ohms at the moment, and this one is 20 kilo ohms. Just wanted to show you the inner workings of this component, because this is also used a lot in simple designs for your Arduino. Okay, the last one here is the DC motor. Alright, speed constant. It has different properties. I'm just going to connect this, stop the simulation again, and then press connect this to the positive and this to the negative. And based upon the voltage applied, it will turn. Yes. If you would like to, I'm going to remove these. I want to apply this little thing and get a combination of these two working, because I want to vary the speed of which it turns with this device, with the potentiometer, and that's possible. So I'm going to connect that like that to the plus side, so the current is going through the motor and then through in here, and then we're going to go to the minus. Okay, start simulation. And here we go. So here is too much resistance, so it's banking, but I can switch the properties of this little device to, it's set its maximum 250 kilo ohms. I'm going to set it to ohms, and now it will run a lot quicker. Here we go. So now you can, ooh, now it goes so quick, and now it's very slow. Yes. So now you can vary the amount the motor turns by just using this potentiometer. So it's being driven by the amount of current it flows through the circuit. A lot of current turns it quicker, and not so much current, then it's slower. Okay, stop the simulation. Alright, these are the basic components you are likely to use. So this is an input, this is an output. These are the resistance are needed to get all the components working within their limits. This is LED, is an output, RGB LED, also output. So I'm going to go back to my little info page here. I'm going to create a new breadboard, and I'm going to use my first Arduino circuit. Yes, finally, Arduino. Okay, we go to components, and of course we are going to find ourselves an Arduino. Okay, the Arduino I'm going to put down here. It doesn't matter where you put it, because it's auto, it's all auto. So normally you would apply a USB plug here, and you would be able to program the Arduino. That's this chip here. It's the I don't know what it is. It's an Atmel or some kind of microprocessor. The Arduino uses a lot of different types of processors on the board. But anyway, this is a USB plug. You plug it in, and then it's powered. So, but in this case, it's already powered. So what we have here, you see the ports here, digital ports. You've got you have got the ground. That's the we're gonna use that in our designs, and we got 13 pins, of which are PWM, pulse width modulation pins, are these three here. We're gonna use that in the next lesson, because that's how we can turn motors quickly. How we can use it to steer motors using an Arduino. These are the digital pins. These are also output pins. And on the bottom side, we've got input pins. So we've got analog in, and we've got some other power related stuff. Anyway, it's got 3.3 volts and 5 volts, and we've got the ground. So what you use is input, output, and voltage and ground. That's the stuff you're going to work with. So okay, it already has a code loaded on this little piece of board. If I go to code editor, you see there's a LED int, and LED equals 13. Okay, internally an Arduino already has an LED on board you can program. That's this one here I'm having here, and it's on port 13. It's this one here, but it's internally, so it already has an LED, so you can do little tests on it. But I want to show you that you can also use this program to put it on another port. And in this case, I'm going to get myself a component, and of course a resistor, our little lifesaver, because without the resistor all your components would go boom. And if we go to our little LED, put it here, the negative side is here. It doesn't really matter where you put the resistor, either on the cathode or anode side, it doesn't matter. We're going to draw a wire. No, that's not correct. We need to put it on the positive side, and this we need to go to the negative rail. And because this is the negative rail, we also need to connect the ground of the Arduino to our ground rail. Because then this is all connected to the negative rail, and we need to get our positive rail for our next projects. We put it like that. So 5 volts here, ground here, and we got pin 12 to the positive side of the LED through the resistor, and the resistor has a value 1 kilo ohm. That's more than enough. Let's put it at 500 ohms. 500 ohms. You can see the color banding change. It's a whole art to it to just know the resistor value just by color. Then you know somebody who's working inside the electronics, if they know that they are working inside electronics. So start simulation. Here we go. You've got the one LED blinking, and this is not working. Of course not, because we need to program it to do something. So I go to code editor, and I've got an LED not on pin 13 but on pin 12. So I change the 13 to pin 12, and the rest I leave the same. So I upload and run, and there we have it. This would be your first blinking LED from port 12. And as you can see, you can just change the value on the fly to measure 300. 1, boom. Actually, the LED would break, but also your Arduino would break if you're not careful. The Arduino can also deliver some power, but it's not meant to deliver power. It's not a power supply. So this way you can just, resistance, put it up at 300. There we go. So now you know if you get a resistor of 300 ohms, then this would not break. It would just blink this LED. Okay. So yeah, this is a really easy circuit, and it's like an hello world for Arduino. And in the next lesson, I'm going to develop more, a much bigger insight into the circuits you need for the Arduino. So I hope you enjoyed this lesson, and see you at the next one.